gonna get started, you guys. I'm excited to introduce to you today's guest, somebody who I've known for several years now, and have been somewhat of a mentor to, as well as hopefully future research collaborator of. Andisheh Ranjbari is currently an assistant professor in civil and environmental engineering at Penn State, but she has a long history before that. She did her PhD at the University of Arizona, more in transit research. So if you're wondering after this presentation why it is that Dr. Watkins asked her to come, then come to Transit Lab and you'll hear the rest of the story. But then more recently, she did a postdoc and was a researcher at the University of Washington. And there she did much more of curbside management, micromobility, and freight research. And so today you're going to hear a little bit more about those last few things. So I will turn it over. Thank you for coming.
Thank you very much. Good afternoon, everybody. Thank you for being here. And before I start, I want to thank Dr. Watkins and ITS Davis for inviting me here. Happy to be here. My name is Andisheh Ranjbari. I'm an assistant professor at Penn State University. And as she mentioned, I was at the University of Arizona, then University of Washington, and then I moved all the way to the East Coast. Starting January 2020, I took on this new job, and I'm now at civil environmental engineering at Penn State University. My research over the past couple of years have been public transit, urban freight, and curb space management. So I would like to characterize it as I've been looking into planning and designing our streets for people and goods. And from the methodological standpoint, I've been looking at travel behavior and network design, and also empirical analysis. I know that you have a high focus on policy here at Davis. So for today's presentation, I have picked some of my curb management and urban freight research that I have put together, and I'm going to talk about it. And yes, if you're interested about the transit, then come to the afternoon session and you will hear the rest of the story as Dr. Watkins mentioned. All right, so I will start with a quick background of why this is important. Then I have 4 different studies that I have kind of woven them together to create a story about curb management and urban freight. So the first one helped us better understand the behaviors of delivery vehicle drivers and the challenges that they face in urban areas in finding parking. The second and third are kind of the solutions that we propose for those. So I present 2 field tested studies, 2 solutions that we tested in the field, and I present the results of those. And then I want to conclude my presentation by discussing some of the trade-offs between different curb space type allocation. So let's start with why this is important. So this is there are 2 parts of this. There's a supply part and there's a demand part. I don't think I need to explain to any of you in this room that e-commerce has been booming over the past couple of years. So there have been just exponential growth in e-commerce and people ordering things online and waiting for their deliveries. At the same time, our cities, our streets, our curbs are not quite ready for that. So these 2, this one is from the Seattle DOT, and it shows that only a small percentage of the curb space in urban areas are dedicated to commercial vehicle load zones, CVLZ. I'm going to mention that quite a bit during my talk. So CVLZ stands for commercial vehicle load zones. So that creates the issue here. So as you might have heard about it, might have not paid attention so much, but it creates insufficient curb or parking space, which also increased in some of the parking externalities. So when commercial vehicles do not find a place to park, they show different behaviors. They search for parking. So they may go around the block, search for parking. They may park in the travel lane. cause congestion issues. They may idle, cause emission issues. So all of these will result in some of the externalities of congestion and emission. And if they spend more time looking for parking or just being challenged with finding the parking, it also means that they can perform fewer deliveries during the day, which results in increased costs for the carriers, and also eventually that cost would be burdened by the customer. So the problem here, just to rephrase that, as e-commerce is growing, cities are grappling with coming up with effective strategies to better and more effectively manage e-commerce. However, there are some challenges. So there's a lack of data. We don't really know how commercial vehicles are behaving, what are the exact behaviors that they show. We don't have enough curb space to supply the demand. And there are some solutions out there. Like we know that this solution could potentially help. This one could potentially reduce some of the parking externalities, but we don't have evidence for that. So these are some of the challenges that I'm trying to talk over today and introduce some of the research that I and my colleagues have been doing. So I start with the first one. I really like this study. We performed ride-alongs with some of the carriers in Seattle, Washington. So we asked some of the delivery companies if they can spend a day with them, ride along with them, and get a better understanding of how their day is being spent. What are the challenges they're facing? How are they behaving in different situations, and so on. It was a really fun research. So our students actually got to ride with those delivery drivers. They get to not only understand those better, but also appreciate the work of the delivery drivers. Our research question was more on the parking side. Where do they park, why, and how long? So you see here some of the pictures. These are some of my colleagues and some of the students that they got to wear the UPS uniform. So UPS was one of the carriers that agreed for us to ride along with them. So they got to wear the uniforms, spend the day with the delivery drivers, and shadow everything that they do from the time that they leave the depot up to the point that they deliver to the consumers and then walk back to the vehicle and so on. We worked with different carriers who are delivering different items. They had different vehicle sizes. We collect in total about 30 hours of observation, and there are some other stats. If you're interested, for all of the things that I talk about today, the paper is listed in the bottom, so feel free to read more about it. I just tried to give a quick summary of these studies. So we did this study, we collected a lot of data, and we found a couple of interesting things. So this was one of the very few studies that actually shed light on the challenges that delivery drivers are facing and how are they behaving. So I'm going to share some of those with you, but basically what we did, so those students who were riding along drivers, they collected GPS data. And we collected, in addition to the GPS data, some of their parking data, like where do they park, how do they perform activities, and some of the qualitative observations that maybe the GPS data cannot tell you. So it would be like something in addition that helped us later on to better understand the patterns that was going on in those data that we see. So let's take a look at some of them. We found that delivery vehicles actually spend most of their time parked. So 80% of their time they are being parked. So that tells you a little bit about the issue about lack of scarcity of the curb, lack of enough curb space. We found that they are trying to minimize conflicts with other vehicles. So some of you might have seen this FedEx truck or UPS truck or whatever parking somewhere that you don't like to see there, but you don't really know the decision making that went into that. So they were trying to minimize the conflicts with other users. They were trying to stay safe. And so there's a lot that the delivery drivers do. And when I mentioned at the beginning that it was fun, but it also helped all of us appreciate the work of the drivers, because we got to experience firsthand some of the challenges that they were experiencing. We found that actually, despite the maybe common belief that drivers, commercial vehicle drivers, want to park in the travel lanes, actually less than 5% of the time that happens. But maybe because they are big vehicles, because they are noticeable, you see them and you feel like that happens all the time. And in terms of the where they are parking, we found that if they have a long dwell time, and by dwell time, I mean the time that they spend parked at the curb or wherever they park, if they have a longer dwell time, they actually do park in authorized spaces. So they don't park illegally, they don't park in the travel lane. Only if they have a short dwell time, like they want to deliver something for 5 minutes or so, so being quick. Only during those times is that they just park wherever it's easier and safer for them to minimize the conflict. The other thing that we noticed, this came from some of those qualitative observations that I mentioned. In an event that they don't find parking that works for them, parking space that works for them, and by working for them, I mean like sometimes it's not, the length of the parking space is not long enough, or it's somewhere that if they back out when they want to get out of the parking space, it creates unsafe behavior. So if they don't find a parking space that works for them, they show one of these 4 behaviors. They queue, they go around, cruise for parking, they reroute. So instead of delivering to this space, well, they cannot find a parking space, so they go around the block, they come back, and they do the delivery later. So it increases the vehicle miles travel, but they do that, they still perform their deliveries, but they spend more time traveling. Or they just park somewhere that is good for them, and they spend more time walking around. So let's say they are supposed to park here and deliver to this location. They know that parking on this block is hard. So while they are parked there, they do all the deliveries to other areas as well. So those are some of the behaviors that we saw that in general, we can classify those behaviors into these 4 areas. Now, with those understanding, then what can we do? What are some of the solutions that we can offer? So we studied 2 different solutions that I'm going to talk about, and we field tested them. So these are all these are both pilot studies and empirical research that I'm going to talk about. One is parcel lockers. The other one is providing curb availability information to the drivers. I start with the first one. So by parcel lockers, just to make sure we all understand, because I know you all have different backgrounds, they are multi-compartment storage systems where you can order something online and it will be delivered to the locker. They have a digital keypad, so you will receive a code that at your convenience, you can go to the locker, enter the code, and then redeem your package. You might have seen those Amazon lockers in town, or some of you in the apartment buildings might have those. So parcel lockers are emerging as a potential solution for addressing some of the delivery issues in the last month. Why? Well, if you don't have a locker, you have to deliver to multiple locations. If it's an apartment building, you have to go to multiple floors to deliver to all of those. If it's a neighborhood, you have to go to multiple addresses to deliver the package. With the locker, you just go to one location. So you go to the lobby of the building, you deliver everything, or you just deliver everything from the neighborhood to that locker, and then people will come and pick them up later. So by consolidating packages in one place, lockers do provide delivery density and reduce delivery times. That's something that has been known. That's because of the nature of how they work. And they have been shown to be, and they have been known to provide these potential benefits. So reducing the vehicle miles travel, reducing the failed deliveries, because you cannot be missed. Your package will be delivered to the locker. You don't need to be at home when your package arrives. So there wouldn't be a second attempt or third attempt, which reduces the vehicle miles travel again. So they have been known to have those potential solutions, yet there has been no empirical analysis of actually proving that or showing how much they would actually reduce delivery times. So our research question was that, do they actually reduce delivery times? And if so, by how much? So we took on this research and we designed a control experiment that I'm gonna just show an overview. Happy to answer detailed questions later. We were looking at the impacts of lockers on time spent inside the building and also the time that vehicles are parked at the curb. The first step was to install a locker. So we took on this ambitious research. We installed a parcel locker in a multi-story residential building. I won't bother you with all of the steps that we took into doing that, but let's say if the whole project took a year and a half, a good 9-10 months of that was just this first step of installing the locker, getting all the paperwork and agreements and permissions and so on. So we installed the locker in this building, and then we decided to collect the data. Do you see the white parts? Barely. Okay, we collected the data before and after the locker installation in our study building and a control building. So if we were just looking at our study building and see how much delivery times changed before and after the locker installation, we could have overlooked something. There could have been changes in traffic congestion, in the weather, in the patterns, and so on. So we wouldn't know if is it just a locker or are there different impacts. So we designed a controlled experiment. We picked another building very similar to our study building, same size, same number of households, same neighborhood, so experiencing the same traffic congestion, as similar as it could be. And so we collected the data for both of the buildings before and after the study. And we applied a causal inference method. So basically, the underlying, the fundamental assumption of this causal inference method is that because these two, treatment and control buildings are the same, they change in parallel. So that's those parallel lines that show, excuse me. They change in parallel, and if if they don't change in parallel, then the difference is because of the only thing that is different, which in this case is the locker. So we collected the data and we built regression models using this method, and we control for several factors so that we make sure that any change that we see is because of our treatment, which is the locker being installed. And so we control for multiple factors, and this is what we found. So clear final results. I'm happy to answer questions about the methodology, but I just give you the gist of final results. So we found that in average, lockers reduce the delivery times inside the building by 50%, and they reduce the time that vehicles are parked at the curb by 30%. So this is the first empirical study that provides some measures of how effective lockers are in reducing delivery times. And so that gives the planners and policymakers and decision makers an estimate, some benchmark of how effective this solution is. Moving on to the next one. So the second strategy that we wanted to test was providing curb availability information to the drivers. What do I mean by that? So you probably use Google Maps all the time on your for different purposes for navigation. Now, if you use it for parking, it sometimes tell you that parking is available. It's like it's scarce. It's busy, not too busy, and so on. But it doesn't provide exact information. And for commercial vehicles, that's another thing. Remember those behaviors that I mentioned, that if they don't find the parking, they may have to go around the block, they may have to double park, they may have to form a queue or so on. What if they know where they are going, there's actually a spot available for them? Or I will be there in 15 minutes. There's not a spot available now, but in 15 minutes, there would be a spot available. So then they can plan better. If the spot is not available there, but it will be available in 15 minutes, well, maybe I go in this place and then do my deliveries and come back there. Instead of going there, see the spot is not available, maybe have to park in the travel lane, maybe have to cruise for parking, double park, and so on. So that was the theory, that was the assumption, but we wanted to test that to see how effective that is. So that was our research question. Can it actually reduce cruising for parking? Can it improve delivery efficiency? So again, we took on a very ambitious research, and we developed a real-time curb occupancy information and prediction app, and then use that. So I will just give a quick overview of that app development. That's not the focus of what I want to talk about. I want to talk about the actual result of that. But basically, the first step was to deploy the sensors in the ground so that we can have real-time information about whether the curb is available or not. So kudos to all of our partners. This was a huge effort. So we installed sensors, commercial sensors, in a study area in Belltown, Seattle, Washington. We installed magnetic field sensors in CVLZs, commercial vehicle load zones, and also passenger load zones, because in Seattle they are next to each other. So they are exactly adjacent to each other. And then based on the information that the sensors were giving us, that was real-time information. And with our partners at the Pacific Northwest National Lab, we also use the historical data and some machine learning techniques to come up with predicted occupancies. So we would have not only if the space is available or not, if it will be available in 5 minutes, 10 minutes, 15 minutes, based on the historical data. All right, so the app was built. Now, we had that app, so we could do our research. Is that effective? Does that really reduce the cruising time for delivery drivers or not? So we designed a randomized experiment. Again, similar to the locker research that I mentioned, we had a treatment and we had a control group. Treatment would be delivering with the app. Control would be delivering without the app. So we created some synthetic delivery manifests. So you're the driver, this is your work for today. So you have to go to these addresses, you have to deliver this many packages, and you start at this time, end at this time. We hired drivers to perform those synthetic deliveries, synthetic manifests that we created, and we collected the data. So we collected GPS data and all of the others, similar to the first research that I mentioned. This was the scope of what we did. So we made sure that every driver did at least one delivery with the app and without the app, so that we could cancel out the random impacts related to the same driver or the same manifest. Different manifests were also done by different delivery drivers. So we did we designed a randomized experiment so that we could cancel out any impact of, oh, it's the same driver, it's the same manifest, or so on. We collected the GPS data. This is a total of what we did: 33 routes, about 500 deliveries, and about 170 stops. And we built a regression model. We applied this specific model, the mixed random intercept regression, because it canceled out the effects from duplicate drivers and duplicate manifests. We built the model, and again, I'm going to show final results. We also control, so we added some covariates to make sure that we are controlling for some other variables, and our variable of interest is what we are actually interested in. So our variable of interest was cruising for parking, searching for parking, and also the total travel time. And this is what we found. So 28% reduction in cruising for parking. So they would have the information, either real time or predicted. So they didn't have to cruise for parking. And also their total route time, the total time spent driving from the time they leave the depot to the time they came back to the depot, that was also, we saw about 16% reduction. So again, the first empirical study that actually quantifies the impacts of providing such a system to drivers. Why are these important? I mean, we know they are reducing cruising time, we know they are reducing that. I mean, in theory, we know they work, but it's important to have the numbers for those because it can help changes the decision that policymakers make. It can help the carriers, delivery companies know that, well, if this is super helpful, then maybe we should integrate that into our navigation system. It will just help people showing how much these are impactful, how much they are important, could result in changed policies or new strategies and new solutions. Now, I talked about two empirical research. Very quickly, I went through all of those, and they are great. Empirical research, I think, is very important, especially when testing new solutions, so that you can have some measures, you can have some benchmarks for how impactful they are. But pilot testing is a lot of work. So it's just like I mentioned that first step installing blocker, first step installing sensors. But I mean, yeah, they are first steps, but they take a lot of time. They are really time intensive, and they are also strategically really hard. I enjoyed doing those. It was really fun to actually do those underground things, but they are not the solution for everything. I think we need to have those pilot tests and empirical research, but especially for larger scale implementation, they may not be the answer every time. So an alternative way for doing that is to use simulation. And I want to conclude my talk by showing a study that we are currently doing through simulation. And again, this is about the impacts of curve management. And then we can maybe talk about the pros and cons of those and answer any questions that you have. So this is a study that I've been doing over the past 1 and 2 years, and it's still continuing. We just had our paper accepted this week, so I just put it there last night. It should be published this week. So what we did in this study, we developed a simulation framework, a micro simulation framework. Micro meaning at the micro level, so we looked at the block face level. We developed a simulation framework to help us see the trade-off between different curve allocations and how they can impact different metrics. What do I mean by curve allocation? So a certain piece of your curve could be for paid parking. A certain piece of that could be for passenger load zone. It could be for CVLZ, commercial vehicle load zone. It could be for buses stop. It could be for bike racks. There are so many different uses for the curve, and it's actually evolving over time, especially with the pandemic. You might have seen those street cafes, so they took part of the curve as well. So there are growing uses for the curve, and cities are just grappling with how complex this is. What should we do? Should we change it to commercial load zone? Should we keep it as paid parking? Should we change it to a bus stop? What should we do? So this simulation framework helped them understand the trade-offs between different curb use allocations. That's what I mean by curb use allocation. So we developed this is a block level. We considered some different blocks next to that so that we can have the flow of the vehicle in the model, but for the performance metrics we use at that specific single block. We use different vehicle types, different driving behaviors, and our research question was, how do different curb allocations and also drivers' compliance impact the performance of the curb? What do I mean by driver compliance? So let's say this portion of the curb is for commercial vehicle load zones. If you are a delivery truck, you can use that for loading and unloading goods. But do drivers use it or not? Maybe, maybe not. Maybe they just park somewhere else. Remember what I mentioned at the beginning? They want to minimize conflicts with other users. They want to be safe. So even if they have a designated space, they may not use it. The same thing for paid parking. We don't always park at paid parking. We should, but sometimes it's closer to our destination. So we just make a quick stop, drop off someone or pick up someone and then go. So driver compliance is a different part of that. We try to introduce some variations in the model to also account for that. All right. So we defined several curb performance metrics. That was the first thing we do. Again, I think you're not seeing the white parts. For people and goods. So traditionally looking at these performance metrics, people have been looking at the passenger metrics. So the productivity of that, the accessibility of that, and so on. Well, what about goods? So how many, in addition to how many people can this block face serve, how many goods can this block face serve? It's accessible for passenger vehicles. What about commercial vehicles? So we defined, so one of the contributions of this work is actually defining metrics, not only for passengers, but also for goods. So we defined productivity index, how many passengers or packages are served per space per hour. We defined the accessibility metrics, and we also defined the emission index. For the emission index, we calculated different driving states. So if it's driving, the emissions produced are different than when it's idling, than when the ignition starts. So we included all of those different states, and we followed this. Again, happy to talk about the details, we'll just go through that. So we defined these metrics for goods and people, and then we defined several scenarios. We had a baseline scenario where along the curb, it was all paid parking. Then we started changing those. So change one of those paid parking to a passenger load zone. Change one of them to a commercial vehicle load zone. Maybe do both of those. The PhD student I was working with became creative and come up with these names. So you see a utopia where everybody has their own designated space and everybody's following the rules. Great. We also have this one, Fury Road, where we have those spaces, but do they actually park in the designated authorized space? No. Do they double park? Yes. So we came up with those different scenarios which account for rule following, compliance, and also different curb allocations. We simulated all of those. For each of them, we had different ranges for the parameters, like the vehicle speed, the volume, dwell time, so that we make sure that we cover a range of scenarios. And then we simulated all of those, and there are a lot of results. The objective of this study was to come up with trade-offs. So happy to share the results with you. Actually, the paper will be published soon, so I can share that with you. And you can see the details of the improvements, or like how much it's getting better, how much it's getting worse, but just the general thing. So we found that allocating curb space for a single use, CBLZ or PLZ. So if you say that this space is only for commercial vehicles, others you're not allowed to use it. This space is only for pickup drop-off, others you cannot use it. That could actually reduces paid parking attempts. It could reduce cruising for parking and emissions. We also found, because one of my focuses on urban goods movement and commercial vehicles, we specifically look at those commercial vehicles. We found that in cases where they have to compete with others for curb space. Remember, for example, one of the scenarios was that paid parking, PP stands for paid parking. Paid parking is open to all vehicles, so any vehicle can park there. In those scenarios where they had to compete with other vehicles for a piece of the curb, their metrics, the goods metrics, actually reduce. Other metrics sometimes increase. So for example, the passenger productivity or passenger accessibility increased, but that's the whole reason we defined goods metrics as well, because we wanted to see the impacts on commercial vehicles. And then we also saw that in different scenarios, so we have 3 metrics: productivity, accessibility, and emission, and also for people and goods. We saw that when we have a space designated for commercial vehicles, then the metrics for goods increased. We saw that when we had a single use or favor toward the passenger or TNCs, then the passenger metrics increased and the goods metrics decreased. There was no scenario where we had an improvement in the passenger metrics, goods metric, and emissions. It was only one of them. Only in one of the scenarios, and that was when we added a CVLZ. That was the only scenario that at the same time we saw an improvement in the goods metrics and in emissions. So emissions went down, goods metrics went up. That was the only scenario. So what is this one telling us and why is it helpful? So curb allocation and curb management is a very complex process. This research helps cities make decisions based on their goals. So we're not coming up with a recipe that, hey, we should all do this. Based on their priorities. So for example, if Davis's priority is to reduce emissions, then they should go with that curb allocation, that is a specific one that results in reduced emissions. If their objective is to increase goods productivity, then they should go with that one. So based on their goals that they have and based on the weights of different priority and goals that they have, this simulation framework can help cities understand what the strategy is best for them and go for it. So I wanted to conclude my talk by just emphasizing that this is a complex process, but the tools that we are developing, the research that we do helps cities, planners, decision makers, policymakers with data and with information and with tools to help make better decisions. Thank you very much for your time. I also wanted to, I had the papers, you would see my co-authors, but just wanted to thank all of my co-authors and all of our sponsors and partners. So we wouldn't have been able to do this without the help and support of all of these partners. Like I have this one specifically here. We are so grateful for that apartment building that let us install a locker in their lobby. They wish to remain anonymous, but I just wanted to thank them. All of these, grateful for all of our sponsors, partners, and my wonderful co-authors. And thank you very much for your time. Happy to answer.
Oh, yes, thank you very much for your presentation. I'm interested in the second study, the second experiment that you did, where you installed sensors throughout the city.
Okay.
How do I say, what was the total cost of that? How do I say, what was really the per sensor cost?
I don't remember that off the top of my head. I can look up the numbers and let you know, but yeah, I don't remember the cost per sensor.
But it was a high cost, am I correct? Based on your,
not per sensor.
okay.
Not per sensor. So sensors are actually, as I remember, were cheap, but it was the process of like digging the pavement, putting the sensors into the ground. And you may wonder why we chose to do with those, because I mean, another way to do that is to install cameras, right? It was because of the Seattle had this, they have this rule that I'm forgetting the name of that they do not allow cameras because of the security issues. So it's one of those sanctuary cities that is, because it's closer to the border. Yeah, do you remember what policy I'm talking about? I'm blanking the name of
Sanctuary
that.
city?
It's one of those cities that does not allow cameras. So for example, for this similar project, we also worked with the city of Bellevue. So in Bellevue, we installed camera sensors. In Seattle, we had to, that was the only way to go.
Thank you.
Thank you for your talk. Really excellent work, all of it. I have a question from the same study. I was just wondering, like you said that you collected historical data trying to be able to predict when the parking spaces would become available. So I was just wondering which data is that? Is it secondary data, and like, does it kind of tell you how long trucks usually park? Like, what is the
So it was the same sensors. We let the sensors in the ground for a couple of months. We collected the data. That was the historical data that I mentioned. So we collected the data for a couple of months, and then we used that data for our model to kind of as a training data to build that model for the prediction.
Third question on the same study. I sort of want to jump back to the question about feasibility and cost. Like, is that something that like the city could have done reasonably cheaply, or not cheaply, but like, is that feasible at least?
So it depends on the budget of the city, but it wasn't very expensive.
Okay.
So this project was sponsored by the Department of Energy grant. So we used a part of the grant to actually buy the sensors, build out. So we paid for the whole thing through this grant, and we still had a lot of money to do the rest of the project. So it was not expensive. I just don't remember the exact cost of that. And yeah, but I remember like the sensors were just not that expensive, because at some point you would, why I'm saying that, because the plan was to install those in commercial vehicle load zones. And then we had this discussion, and the city of Seattle was saying that, well, our passenger load zones are also exactly next to those. So we see that sometimes commercial vehicles park in those. How about we also install those in PL6? And we're like, yeah, sure, that doesn't, like, it's not that much expensive. So we ended up doing that as well.
One more question on that. Was that data published publicly, or was?
Yes.
Okay, so
Yes.
other people were also able to see that.
The data?
Yeah. So you were, for people, like when you were doing your tests, your experiments, the drivers were competing with people who had access to the same technology.
So you're saying about the app?
Yeah, the app.
Yes, the app is publicly available.
Okay.
It's a web app though, so I mean, you have to, so it's not downloadable by App Store or whatever the equivalent of that is, but it's a web app, so you can put the address in it, and yeah, everybody can use it.
Thank you so much.
Thank you so much. Very interesting 3 studies. I think I'm more interested in the locker one
Good.
at this moment. Yeah.
New question.
Yeah, but it was because I was thinking that it seems, or I don't know if I didn't see it in the, like if you were taking into account the neighborhood type and how different, you know, maybe lower income, higher income neighborhoods would manage lockers differently, and you know, possibly that it could be something more like maybe catered for like maybe more middle high income neighborhoods, and you'd still get all the other problems still in the other neighborhoods, and also in general. But the first study as well, like the first study in the equation, there's nothing about that type of neighborhood, and so I don't know if you are planning to incorporate something like that.
So in both of those, we had a small, so the locker was just one locker, so we installed that in one apartment building. The sensors were just one neighborhood that we did that. So no, we did not. It would have been very nice to install those in different locations with different income levels and different sociodemographics, but we did not do that. So that was not a factor in our question, because it was homogeneous. Like for the locker, it was, I mean, all of the people living in that apartment buildings, because the rent is the same, you would assume that they are about the same income level. And for the sensor part, it was the same neighborhood, I guess about 10 blocks. So it was also homogeneous. So no, we didn't look into those disparities, income disparities. Yes.
Yeah, so with regards to the locker project, so basically you saw that there was a reduction in the basically dwell time and like overall emissions related to that specific apartment building where the locker was installed. I'm just kind of curious, like, why do you think that was that? Like, you think that maybe the drivers were more efficient in dropping off the packages, maybe they didn't go in like up to each individual apartment, like kind of why do you think it is that?
Yeah,
result?
so I showed a picture that was with lockers and without lockers. So when you don't have a locker, and this can also be true for consolidation centers. So when you don't have that, you have to actually deliver to, if it's an apartment building, you have to deliver a specific tenants. So you have to deliver them. If it's a neighborhood, you have to deliver to specific addresses. But with the locker, you don't do that. So let's say that you park your vehicle here, and then you go to the building. It takes you more time to go to different floors and deliver, right? But with the locker, you go with your dolly to the lobby, you put everything in the locker, you go back. So it saves time. That's for inside the building. Now, in terms of the amount of time that was parked at the curb, honestly, I think if other buildings had also lockers, you would have seen much more reduction in the dwell time. But because only, like the change was only in one of the buildings, because usually vehicles park there and the drivers deliver to multiple buildings, right? We wouldn't see a reduction in the other buildings, but for that one building, there was a reduction. So if you notice, the change in the time inside the building was very significant. The change in the dwell time at the curb was smaller and not significant because it was only part of the dwell time that they had.
Yeah, you mentioned that about 80% of the time is spent in parking issues, but this number cannot be reduced up to zero because drivers should spend some time like parking, right? So do you have an idea of what's the perfect proportion of between parking time and driving time for regular deliveries?
Not really, no. I guess it would be based on the company's business model, what would be the optimized proportion for them, but I don't have knowledge of the whole plan of the drivers and different manifests they have, so no, I don't know what would be the perfect proportion.
In the D&D model you showed us, I wonder what were the criteria used to ensure that treatment group and the control group remain consistent in other factors, because which is very important because the conclusion was the reduced time come from the factor difference between treatment and control group. Then there's all sorts of factors maybe.
Absolutely.
Yeah.
So yeah, that's why we actually spend a lot of time carefully picking the control building. So the factors we looked into, the same number of tenants, because that impacts the number of packages that they order. Well, similar number of tenants, similar number of households. They were in the same neighborhood, so there was different traffic congestion patterns. Also, the availability of commercial vehicle load zones around the building, that was also a factor that we looked into, so that they would have similar, because if one building had more load zones around it, or one didn't have any, and vehicles had to park farther and deliver to the building. So similar load zones, and we also collected the data around the same time, so that in terms of weather and everything, it would be the same. So our treatment and control buildings had similar characteristics, so that we would be confident that the change we see was not related to other factors. It was related to that only change, which is the installation of the locker.
To share how many observations there, like to compare their two groups? Like you
How
collect
many
the data over
observ-
time, multiple times, right?
Sorry, say that again.
I mean, like the data collected at different time and different time of day, different
Yeah,
day
yeah,
of
yeah.
weekend.
Yeah.
And weekends probably too, like how many variations or observations in that data?
Yeah,
to
so
the
I don't
next?
remember that off the top of my head, but I can send the paper to you. Yeah, so we collected data during weekdays, during weekends, different days of the week, and different times of the day as well. We would send data collectors around the same day to both buildings. They would collect the data, each of them. I think for each shift, data collectors were there for 3 hours. So each of our shifts was 3 hours. They were collecting data. And so yeah, I can share with you how many observations we have for each of those. I will send you the paper. Send me your email and I'm happy to share that.
Appreciate.
So first of all, before you did the locker solution, have you looked into like on-site mailboxes for apartment complexes or like on-street mailboxes for a neighborhood? I think that have similar idea. And the second question is, does the size of the package impact the locker, like how the lockers are utilized and also how long the dwell time is? And the third question would be, how does the bike infrastructure, like since we're in Davis, how does the bike path or like bike infrastructure could potentially affect how you design your curbs through different like combinations and stuff, and how that these bikes just keep going, they don't stop, they don't stop there for like a solid 5 minutes, so you cannot predict that as easily as you do for the curb design. Just kind of
So remind me if I forget the question.
first one is just before the locker. Have
Yeah.
you compared it to the mailboxes?
So if we had anything in the neighborhood, no. So we looked around, we didn't have anything in the neighborhood. In the building though, yes, we did analysis of before and after. So what happened in the building was that before the locker was installed, delivery drivers would come in. If it was an extra large package, it would go to the 4th floor of the building. Otherwise, they would deliver them to the people to their doors. What happened after the locker, oversized packages still go to the 4th floor, so that didn't change. The packages would be all delivered to the locker. All tenants, again, thanks to the apartment building management, they automatically registered every person to the locker, so it wasn't a choice decision. So all the packages would go to the locker after the locker installation. So did that answer your question on the first question?
Not really. It's like how have you compared, because yes, delivering mail and delivery packages are very different, but we already have a lot of on-site mailboxes. and
Sorry,
on-street
I got
mailboxes,
that
right?
wrong.
So, yeah.
So there was a mailbox for like envelopes and so on in the buildings. That remained unchanged. So small like envelopes would still go to that small metal mailboxes. So this was only for packages that I mentioned.
Yeah,
Before
so
the
have you
locker,
compared the, like, how does USPS deliver mails? And this, they could go knock on each door, they can just deliver mail to each door. But then since some apartments have like on-site mailbox where all the apartment numbers to be in one like place where you just go there and you put all the mails in their respective boxes, that's a similar approach on.
so are you saying
lockers, right?
comparing
Yeah.
mails to every tenant as opposed to putting the mail in the mailboxes?
Yes.
So we did not have that data because the mail, the mail situation did not change. It was the same before and after the locker, and since we were only looking at that study building and that part did not change, we didn't look into that. So the only thing that changed was the package delivery. Mail delivery and oversized package delivery did not change, so it was just the packages, like those boxes that changed, and we only measured that. So we excluded any mail delivery if you're asking. So for example, if we would see a USPS driver going into the building, we would eliminate that from our observations because it would have done the same thing before and after the locker. Did that answer your question? Okay. And what was the second question? Sorry, remind me.
So question is, I mean, kind of answered the size of the packages. Can we move on to the third question? Bike infrastructures, how does that affect like how you design your curbs?
I think so. We didn't include that. So in the simulation study that we did not include bikes. So we had paid parking, we had commercial vehicle load zone, passenger load zone, and bus stuff. We did not have that bike, but I'm sure it would affect that. So one way to study that is again to do some of the things we did. So remove one of the paid parking and replace it with like a bike section, or like maybe a bike rack on the curb, and then see the impacts of that. Another way to look into that was that, so if it's a bike lane and vehicles cannot actually go in there and park, so where would they go? So I'm sure it would impact the behaviors and the traffic. We did not study that.
I had a question about the impact the vehicle size in the model, and if that could lead to eventually, restricting the vehicle size of vehicles in the cities. And also, since I did notice that one of the issues was, if the space was big enough for the vehicle. So like, how was that?
Yeah. So which model are you asking about?
But but yeah, like in general, like, could that be potentially one thing that, if you restrict the vehicle size, you would reduce all these problems?
So so I can tell you from the locker study, for example, we did control for the vehicle size, and we did see that dwell time was changing based on the vehicle size. But I'm not sure if we can just say that based on the vehicle size, because, why am I saying that? Because smaller vehicles were also delivering fewer number of packages. Larger vehicles were delivering more packages. So in a way, vehicle size was correlated to the number of packages. So I am not able from our results to say that if it was solely the size of the vehicle or not. So that's from the locker study. In the simulation study, we did see again an impact for the vehicle size because of the space they needed. So like we had standard sizes, but if it was a larger vehicle, it would take 1 1/4 maybe, and then it wasn't room enough for the second vehicle to park, which would mean that that second spot was not available. So vehicle would have to go parking somewhere else. So we did see the impact of that in the simulation study, and that one, I can say that reducing, maybe limiting the size would provide more supply for the parking.
I was interested in kind of a nuance in your simulation framework, but I think that could be kind of critical to effective results. So I remember there are two time variables. The one should be the time cruising parking, and the other is the time, the total routing time. So how do you calculate or log these two variables? And then for these two driving state, the normal driving and the cruising parking, did you apply different vehicle behavior or just a carpooling model in your simulation? And another question is like, what kind of platform did you use for your simulation?
Good question. So the platform for simulation, it was micro simulation with sim. I had the logo there, so it's very common PTV. First question was about
The time variables, how do you calculate it?
how do we calculate that? So great question. So we had GPS traces, right? So we could know the total driving time, total travel time. Now, how did we calculate the cruising time? I can refer you to a study by one of my colleagues, Giacomo Della Chiara. So he actually quantified the cruising for parking, and we actually used his methodology. How he quantified cruising for parking? He used Google API. So the GPS traces the time the GPS gives you the actual travel time. The shortest travel time, he used that through by sending calls to Google API matrix and getting the shortest time, and the difference of that would be the time spent searching for parking.
And then there's still one question missing, like, did you apply different vehicle models when doing the simulation? So, yeah.
Vehicle models, you mean in terms
For
of
example,
types?
if you are conducting normal driving, there should the maximum speed should be, the speed limit of the road segment. But for example, if you are cruising for parking, the following carpooling behavior or the maximum speed, the cruising speed for the vehicle could be different from the normal driving.
So we didn't do anything for that because that's built in Vissim. So Vissim has its own car following model.
Okay.
So we didn't need to worry about that, but different vehicle types and the different car following and lane changing behaviors are all built in Vissim. That's actually one of the reasons we picked this model, because if we wanted to develop our own simulation, we had to develop all of those, but those are already built in. So that's one of the reasons we picked Vissim.
I imagine the delivery companies save some money on labor costs when they install the lockers.
Yeah.
Who pays for installing the lockers? Is it difficult to convince the apartment buildings to install them? What are the economics of that?
So yes, they do save money. Why? Because then the time that is saved from parking can actually be spent on delivering more packages, right? So there are cost savings for delivery companies. Now, who pays for the lockers? The one that we studied was called, is something that we call common carrier locker, which means that all carriers can deliver to that. So Amazon, UPS, FedEx, everybody can deliver to that. Those type of lockers need to be paid for by the city or by some grants. We paid for it by the grant that we had. So all of the costs we just asked for the apartment managers to let us use their space in the lobby, and we covered the purchase of the locker, installing the locker, the electricity, all the utilities, maintenance, and everything. So we just asked for the space for them because this was a research project. However, if it needs to be done, it needs to be paid by an impartial, something like a city. Right now, what companies do, Amazon has its own lockers, UPS has its own lockers. So they have their own locker and they pay for it. There's cost saving for them. So they save costs from delivering to locker, they spend it on their locker. But the issue with that is that only they use it. So it's not a common carrier locker. So there are some, from the consumer perspective, if you order something with UPS and then there's an Amazon locker in your neighborhood or in your apartment building, doesn't really make any changes. So what I explained here, and I should have clarified that, sorry about that, it's about common carrier lockers.
A related question, one may also argue that if there's a common carrier locker, and what if Amazon takes all the space? And USPS has no lockers that use every day, right?
Yeah.
Because they have the volume.
Yeah.
That's probably one reason why Amazon wants it. They have the data, they can control, they can have predictive models.
True. Yeah.
Also, if you have a very large space dedicated to common carrier, then the residents would complain, and you take all of this.
That's another point. So that's why I say that we are very grateful to the management of this building, because some of the residents were not happy, even though our locker was not super large, but some of the residents at the beginning were not happy with this giant infrastructure in our lobby. We don't want that. But somehow the management of the building convinced them. They set up meeting with them, told them that this is for research, we're working with academic researchers. If you don't like it, this is temporarily, this is paid by a grant. If you don't like it after the research is done, we're going to remove it, but give it a shot, try it. And we actually did a survey, and surprising, like at the beginning, people were just saying all sort of things and they were not happy. Some actually complained that I have to go all the way downstairs to pick up my package. I don't want it. I want it to be delivered to my doorstep. But we did a survey. We gave it some time. So we did the survey about, I think, 8 months after the installation of the locker, and 96% satisfaction. So at the conclusion of the project, so we only paid for the locker for a year. At the conclusion of the project, the apartment management asked us for the contact of the parcel company, and they started their own contract. The locker is still there.
Yeah, one of my friends actually works for one of the companies that sells the lockers, and most of their clients are actually just apartment buildings. And the reason why apartment buildings are willing to pay for that is that, I mean, one, it's sort of a sense of security for the residents in the apartments. They don't have to fear their delivery being stolen, especially in cities where that's a lot more of a concern. And you know, it's sort of a convenience thing for them, having everything sort of all consolidated in one space. But obviously, if you have it delivered to your door, that's convenient in a different way. So there's certain trade-offs, and it has to be in the right type of market where the security risk is considered something that's worth value, right? If you're in a market like a rural place, you know, the risk isn't very high, so the value is not there.
Yeah, true. And I would like to mention that the one that so we paid for 3 lockers out of this grant. We installed this one in a residential building, one in a commercial building, and another one, a public locker, like on the street. Why did I present the results of this? Because this was the one that we got the highest adoption, and we had enough data to actually perform this study. The other ones worked. I can tell you how many calls I was hung up on and how many people rejected me when I was calling them, can we install a locker in front of your building? Can we install a locker in the parking lot? Blah, blah. I made so many phone calls and emails and presentation and pitches so that people could let me install a locker, well, let us install a locker. But this one said yes, and they all worked with us to achieve a high adoption. But in the other 2, we didn't have enough adoption to have the data. Go ahead, I can listen.
In the simulation, what was their unit of analysis from the data to feed their model?
What do you mean? Unit of
Like,
analysis?
in the simulation, you need the data inputs to put things out, right? What was the unit of analysis collected at the beginning to do that simulation? What I was interested is, did you consider like the time of the day? Because whatever happening in that simulation is always associated with a lot of different purpose compared to the street space, but the computer space at different time of the day.
I understand the question. So we did this only for the A and peak period. And we used ground truth data to build into our model. So we built our model based on the traffic data and parking usage data from A and peak. But that wouldn't impact the validity of our results because we had a baseline scenario and we compared everything against the baseline. So it would have been wrong if we built something for the AM and compared the changes in PM, for example, or another weekday. But because the time of day situation and the volume input and everything was the same for the baseline and the scenarios, we basically compared the incremental change between those scenarios.
In the process, did you or team realize the time of day actually matters in that process? Because the package delivery, the time of day doesn't really matter for the package delivery. Like we receive the package actually at a lot of times of the day, right?
So are you asking about, you asked about the simulation, but are you talking about the locker one?
The simulation.
Okay.
Yeah, because we can actually say the time saved, right? Like when you do the ride routing, like experiment.
For the simulation one, there was no experiment. So are you talking about the last one? So we only built the model for the AMG, and then we compared the results against each other. So time of day was never a variable. For the other two, it was a factor, and we did include that in the model, and yes, we saw differences for that. For the locker and the parking availability app, we saw that as a factor for the simulation, because all of the scenarios were for the same period. We never ran any scenario for other time periods. We could not see that impact.
Okay, sure, thank you.
Sure.
Can't see the online ones, just kicked me out of the meeting, so I can't see, yeah.
Okay, all right.
Okay, all right.
The only question I remember is that, when people wanted you to clarify what some of the abbreviations and acronyms meant, I think that was like on the last slide.
Yeah, it was probably the CBLTs.
Yeah. Yeah.
If they missed the beginning, it might not have made sense.
Yeah. I realized, I looked at my slides this morning, it was like, I should have put footnotes there, but I didn't have time to do that, so I thought that I would just say that at the beginning.
If we lost them,
Apologies for
it
that.
may not
Yeah.
matter.
Yeah. Any other questions? Thank you very much for being an engaging audience, and happy to chat more and provide papers.
Thank you.